Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are talking about, let's see, question number 7 from RevG, and it is a paper 1. So let's get to it, shall we? So we have a function here, px cubed plus px squared plus qx, and part A says find the derivative. Well, that's easy, hopefully. F prime of x, using our power rule for taking a derivative, is going to be 3px squared plus 2px plus q. Okay, and part B is the hardest part of this question. It says, given that the derivative of x is greater than or equal to 0, okay, show that p squared is less than or equal to 3pq. Now, the confusing thing about that, well, let me first say, if this is greater than or equal to 0, what they're saying is it is always positive, or it can be equal to 0, this derivative, which is right here. And I think the problem, when I first looked at it, the problem I had was I was trying to link it back to the function here, the original function, what the derivative tells me about that. But it's all about this derivative, and the derivative is its own function. And what kind of function is it? Well, it's a quadratic, okay? And so I'm going to draw a little picture here to help us out, to help us understand that, or understand what it is that we can do to show this. So it's a quadratic, and the graph of a quadratic is a parabola. So if it is always positive, then it cannot open down, because if a parabola opens down, eventually it's going to get, like, you know, right here, if it's going to continue down and get into the below the x-axis and become negative. So it's not opening down, so it's going to open up. And if it's greater than or equal to 0, there's really two things that can happen. It can touch the x-axis, yes, or it can be above the x-axis, okay? And we have to think about the solutions then, okay? If it's above the x-axis, then there are no solutions to this quadratic if we set it equal to 0. If it touches, we have, if you remember, it's a double root, okay? And how can we tell that without actually finding the answers? We can use the discriminant, delta, the discriminant. And delta is equal to b squared minus 4ac. And remember, that's the part of the quadratic formula that is, you know, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. It is housed in the square root. So if there are no solutions, then that means that under the square root is going to be negative. And if there's one, or if there's a double root, it's going to be equal to 0. So then we know that delta must be less than or equal to 0, because it's either going to be negative, and if it's less than 0, it would be negative, and there would be no solutions. Or if it's equal to 0, then it would just touch the x-axis right here. Okay? And delta equals b squared minus 4ac. So we are going to say b squared minus 4ac is less than or equal to 0. And remember, a, b, and c are the coefficients of our quadratic. So here is my a, here is my b, and this is c. So we're going to put that into the discriminant, b squared, so 2p squared minus 4 times a, which is 3p, times c, which is q, is less than or equal to 0. And we have to show that p squared is less than or equal to 3pq. So what we really have to do here is just solve for p squared. So that's the hard part's over. So 4p squared minus 12pq is less than or equal to 0. Moving that over, 4p squared is less than or equal to positive 12pq. And then if we divide both sides by 4, then I get p squared is less than or equal to 12pq over 4, and that simplifies to p squared is less than or equal to 3pq. Isn't that lovely? Not so bad once you get to this concept, and that's all there is to it. Hope you enjoyed it, because I am out. See you next time.